Hello, part three now for this week, and hopefully this one's quicker than the last one. I do apologise that it went on for half an hour. I wasn't expecting it to go for that long. But now we're going to go on to rounding and significant figures. This should be quite simple, quite a quick thing. Just the idea of significant figures, and if you're asked to round to 2, round to 3, you know what the game is. So let us revisit my slides. Here we go. So use an appropriate number of significant figures, e.g. when expressing a correlation coefficient to 2 or 3 significant figures. There are no other slides to this one. We're going to go straight onto my my notebook. Significant figures usually it will tell you if it wants 2 or 3. With things like correlation coefficients, you'll want 2. Some things might ask for 3. I'll explain what that means now. So we've not used, what have we not used? We've not used blue yet, so let's go for blue. Let's say you've got a really long number and it's just not appropriate to keep it to express it in full numbers every time. So this is a long number. This is 4 trillion, I believe. It's got 12 zeros, and your conventional notion of rounding, you might think that you round to your tens, round to the nearest 100, round to the nearest 1,000. Significant figures don't work like that. They don't care whether you're rounding to a 10 or 100. It's relative to how big your number is, how detailed your number is, I should say. So this is obviously your ones column. You know, you've got your hundreds column here. This is your billions column, etc. So you might be expected to be asked to round to the nearest billion or whatnot. Not so. What we want to do is we want to make this number still manageable. If you rounded to the nearest 10, you would get 10, and it doesn't represent the number even remotely. So instead we round to significant figures, and significant figures just means the start of the number, really. So we just count along from the start of the number. 2 significant figures, we count along from the start of the number. And the reason they're called significant figures is because you can imagine there's an infinite number of zeros here as well, which we don't count. And those zeros become more relevant when we look at very small numbers rather than very large ones. So if we want to put this into 2 significant figures, well, we just count from the start. One significant figure would, this number to one significant figure would be just 4 trillion. We want 2. So we know it's a 4 at the start, because that's one significant figure. And then let's have a look. It's 3. But then do we round up or down? We could round up to 4. We could round down to 3. Well, look what's after it. After it is a 1. So we know that we're rounding down. Because the rest of this number after here is closer to 300 billion than it is to 400 billion. So we know it's a 3, and we only need 2 significant figures, so the rest of them can be replaced by zeros. So this number to 2 significant figures is 4.3. We're doing 3 significant figures. Again, we have a look what's after it. We think it's a 1. But do we need to round up or down? Well, the number that's after it is a 2. 2's, the bottom, so we round down. You'd never be asked to round to more than 3 significant figures, so we could go further, but I think it's best we stop there, given how long a number I've written. You'll never be asked to round to one significant figure. It'll only ever be 2 or 3. And you should know this particularly when you're doing decimals. And I mentioned the imaginable infinite succession of zeros that come at the start of the number. If you've got 10, there's still a 0 in the hundreds column, effectively. There's still a 0 in the thousands column. But where the zeros become relevant is when you've got a decimal. Let's say we want to round this to 2 significant figures. You've got to remember the zeros are still not significant. Even though they're this side of the decimal, they are not a significant figure, okay? Just as these zeros are, you still don't count the significant figures. They do affect, obviously, they affect the number, but they're not significant. You still count your first significant figure from the first non-zero value as you count from left to right. So obviously that would be 1 significant figure, would be 2 significant figures. Your 8 would be 3 significant figures. Pretend there's some other numbers here. So it works in exactly the same way. Don't be scared that it's decimal. So if we do one significant figure, it would be 0.07. Do we round up or down? Well, 4 is the lower end of the numbers, so we round down. So it's just 0.700. So we could just say 0.07. What about 2 significant figures? Well, this is a bit different to what we've seen so far. 0.74. But what comes after it? 8. How do we round this? Do we round 8 up or down? We'd round it up. We'd round it up to the next 0 rather than down. So this actually becomes a 5. Becomes 0.0750 because the 8 rounds up. So it's just your normal rounding, but rather than rounding to the nearest 10, the nearest 100, we're rounding to the next significant figure. Okay. This is relevant when you're asked to round a correlation coefficient. So you might get a correlation. It might tell you the correlation is 0.7. Actually, we've used a 7. Let's use another number. Let's give them all their chance to shine. 5112339. And it will say, and for this, there is an expectation with correlation coefficients that you round them to 2 significant figures unless otherwise stated. So this would be 2 significant figures as a correlation. Well, we ignore the 0, doesn't count, at least not in terms of the significant figures. First significant figure is 5. Do we round up or down? We round down because the next number is a 1, so we keep this as a 5. Next one is a 1. Do we round up or do we round down? We round down again because the next number is a 1. Don't go any further because we've got our 2 significant figures. We stop there and the rest are replaced by zeros, if indeed it goes any further. So that is rounded to 2 significant figures. You might get a follow-up question that then asks you to comment on the strength of this correlation. So we'll throw in some research methods. We know that correlations go from +1, or we should know, to -1, 0 in the middle. So we know this is a positive correlation. We know this is a negative correlation, obviously, it's positive, negative numbers. Strength increases in both directions. So you can have a strong negative correlation, weak correlation clusters around 0, or a strong positive correlation up here. Remember, positive just means in a correlation just means as one value increases, so does the other one. So a correlation on a scattergram would look like that. Negative correlation would be as one factor increases, the other decreases. Like that. Okay. If you were asked to interpret the strength of this correlation, it's 0.5, which would put it slap bang around here, 0.51. So it's not a strong correlation, but nor is it a weak one either. So you'd say this is a moderate correlation. And that's something that I think is you could well be asked with this type of maths question. A good follow-up is put a correlation coefficient into two significant figures, and then on the back of that, comment on how strong that correlation is as a result. I think really the example given on the specification is rounding to significant figures in the context of correlation coefficients. I don't necessarily think there'd be a reason for you to round anything that's above 1. That's not a correlation coefficient, I should say. But we'll do one example just in case. So let's say you're looking at some huge data, and there were 85,491 people at a football match. Oh no, so that was use football match ball at a concert. For some reason, you want to put this into 3 significant figures. And the question will probably tell you that. Otherwise, you just assume 2, and the mark scheme would credit 2, I would assume, if it was unspecified. You want this to 3 significant figures. Well, we know the first number is 8. Actually, if it had been 1 significant figure, would it be 8? Well, actually, it wouldn't be, because what comes after it is above 5,491. So it's above 5,000. So actually, we would round up. So this was 1 significant figure. This would be 90,000. But we're not rounded at this point, so it's still 80,000. Second significant figure, 5. Do we round up or down? It's 49 is the value here, so 491. So it's effectively just below the threshold at which we'd round up. If this was 5,001, 50, we would round up, because you round up if the next values numbers are 5. As it is, it's not, so we keep it at 5. Next one, 4. Do we round up or down? Well, the next number is 9. It's very high, so we round up. And then we stop there. We've got our 3 significant figures, 1, 2, 3. So 85,491 at constant to 3 significant figures, that's 85,500. You could be asked something like this, but I think it's much more likely you'll be asked in the context of a correlation coefficient. Anything more than that is more than you'd be expected to ask. You'll never, I don't think you'd be asked to estimate numbers. You may remember from GCSE maths where you might have to estimate a number using significant figures by multiplying numbers together. You wouldn't have none of that. It'd just be as simple as putting a number or rounding a number to a level of significance, and you would stop there. The maths demands, they are there, and it is 10% of the mark, so you do need to practice. But it's not strenuous. It's not strenuous. And it's absolutely something that you can go through. And I said I'd put a worksheet together. I will do that, and I'll put some rounding in there as well, and I'll provide the answers on a separate document for you to have a look through. So do have a go at those as well, because they'll be attached to all of this week's sessions. The next session is probability, p-values, and significance, which I fear may be the longest of this week's session. So hopefully see you there. Hopefully this one has been helpful as well, and see you on the other side.